It's recording. Let's revise. Exercise 4C, it is about area of basic shapes. So things that you've seen since primary school. So let's see what you remember. What shape? Oh, actually, there's a name there already. This is called a square. What's one of the key features of a square? Let's go with Hauschwan. What do we know about squares? What do these dashes mean again? All sides are equal. Very good. So all sides are equal. And in that case, the area formula for a square, what is that, Tom? What's the formula again?
Two of the sides times by each other.
Very good. So normally when we say area, we're talking about the space that something occurs or occupies in 2D, which is 2 dimensions. So that's why what you just said was correct, because 2 dimensions is the only way you can get space. If you just have one line, then it's the length. So it's 1 dimension. But as soon as you add in a second dimension, this now covers space. If you add in a third dimension, so now if you've got 1 down, 1 across, then you can go 1 vertically up. That's how you get a 3D shape, which is the box, right? So when it comes to area, you do need 2 sides. So if you can go one side, that's 1 length, and then you cover this entire side, well then all of these will fill out a space. That's called area. So yes, you do need a side length and another side length. But not only just any side length. What do you notice? When you choose a dimension, when you say 3D, they actually connect by what angle again? 90 degrees. That's why most of your formulas, if you haven't realized, they all are connected by 90 degrees because you're always looking for the second dimension. If you have 1 dimension, you're looking for a second one that is connected perpendicularly. Okay? So the formula generally for an area, like a simple basic 4-sided shape or like a square or rectangle, it is length times width. But specifically in a square, since all sides are the same, and even though length generally means the longer side, in a square, the longer side and the shorter side are actually the same. So instead of saying length times width, it was the same thing as saying length times length, because it's exactly equal. Okay, so then in your formulas back in primary school, they might have said length times length or L times L, which gives you L squared. Very good, write that down. That's why they say L squared. But even if you've forgotten, Sully, that was unnecessary, yeah? It's a warning because you were talking outside. And that's a second warning now, yeah? All right. L squared. Write that down, L squared. Even if you've forgotten that, you just need to remember length by length, which is what Tom was saying before. That will generally give you pretty most rectangular type shapes. So you got L squared is for a square. That's the area formula. Rectangle, most students remember this one. It's just length by width, or they'll just say take 1 length times the other side length. Often we say the longer side is called your length and your shorter side is called your width. Okay, fill that in. Then the next one. Usually it's a triangle next, but I thought I'd show you the similarities between square, rectangle, and parallelogram. What's the area formula for a parallelogram? Hands up if you know. Yes, Ollie. Base times height. Very good. It is base, which is actually this entire length on the bottom here. So that's your base. So base multiplied to height. Now when they say height, they're referring to the perpendicular distance between these 2 parallel lines. Again, it's 90 degrees. Okay, it's not the slant. It's always the 90 degrees. We're talking about 2 dimensions that is always perpendicular to each other. This is your height. And the reason why it's base times height, for those who haven't realized, you see the height. If I chopped off this bit, if I just literally cut this one down, that makes a 90 degrees here. But if I took that triangle, it actually fits perfectly over here because in a parallelogram, this angle is exactly the same as this angle. So that should match here The height should match here. So actually this triangle will fit nicely. And you end up with a rectangle. And the area of a rectangle is just literally this length times the width. That's why we call it base times height, but really it's length times width again. Okay? So a parallelogram is really just a rectangle slightly tilted. Okay? So if you remembered area of a rectangle, you technically remember the area of both a square and a parallelogram. That's why it's called a basic shape. Then we go on to the next basic shape. It's the last one of exercise 4C, triangle. What's the area formula for a triangle? We know it's half times base times height. Same thing again. Base is this distance. Height is the perpendicular distance. Okay, and by the same concept, where did this formula come from? We know that in a rectangle, that's your base, that's your height, or you can call it length by width. But a rectangle, if you halve it, you get a triangle. So that's why they said, well, if I just know what base times height is and then I halve it, I should be able to get the triangle. So I just need to know the two perpendicular lengths. I just need to know the length. I need to know the width. That's the reason why the formula works. So really, the one formula you only need to know was a rectangle. If you know length times width, you would have figured out a square. If you know length times width, you would have figured out a parallelogram because it's the same thing, it's just tilted. And then over here, a triangle is the same thing. It's actually a rectangle halved. That's how you get a triangle. That's where the formula comes from. They just call it different names, but by the same idea, base makes it easier for you guys to understand to find the bottom part of a triangle. And height is not the slant. It's always the 90 degrees. And why is it 90 degrees? Because it's two dimensions. We're talking about area. So two-dimensional shape. Talking about space, you need two number lines, essentially. Okay. All right, so that's your basic shape there. That's most of the information that you need for 4C as revision of what you've done in primary school and then leading on to what Year 7 was. Yeah? The other part that I find students tend to forget, which I told the other class, I used to ask back in uni, my cousin is an engineer, a mechanical engineer, and I asked him about a unit conversion that I taught to my Year 8s. And he doesn't remember this because a lot of it is memorized and a lot of it is understood. So I explained to him why this was the case. I'm going to do the same for you guys here. You see, unit conversions, this is called area unit conversions. Most of you already know how to convert things like kilometers to meters, centimeters to millimeters. These are called lengths because there's only one dimension. When you say area, it just means two dimensions. Yeah, and then if you say volume, then it's three dimensions, right? Let's think about lengths. Let's see what you remember from lengths. How many millimeters make a centimeter again? 10. So you need 10 of these millimeters to make just one. So if you think about it, how do I go from 1 centimeter to 10 centimeters back to millimeters? From 1 to 10, the only way to do that is actually times by 10. Yeah? A lot of times if I don't draw this arrow and I don't show you the explanation, most times when I ask students, how do you convert centimeters to millimeters? Most students say times 10, which doesn't make sense. Okay, because if you're going from centimeters to millimeters, the number should get bigger, right? So this is the way to go from millimeters to centimeters, and from centimeters to millimeters, it's then times 10. Okay, not the other way around. So it's actually divided by 10. So 10 divided by 10 will give you the 1, and 1 times 10 will give you the 10. That's the logic. So that means all the timesing should be on the bottom. Okay, millimeters to centimeters times 10. What about from centimeters to meters? How many centimeters make 1 meter again? 100. So this is times 100. I need 100 of these to make one of those. And then you follow the same pattern again. How many meters makes a kilometer? 1,000. So this then should be times 1,000 because I need 1,000 of these meters to make a kilometer. So when you go backwards, that's why this one is divide. And then this one is then divide 100. So most students will memorize that to some degree. right? Okay, I'm going to keep teaching then.
Sorry. Say on.
All right, so what about area now? See, area still follows the same thing. You still times 10 times 100, still times by 1,000. This is still divided by 1,000. This is still divided by 100. And this is still divided by 10. The only difference is, and this is where I was explaining to my cousin, you see, when we talk about area units, it's 2 dimensions. This one was 1 dimension. That was a length. So, in this case here, if I said I have 1 square meter, right, that 1 square there, the way you pronounce this is 1 squared meter. Right, boys? So remember I said when I'm teaching, if you're distracting me while I'm teaching, I get really annoyed. I've already gave you that off when you were catching that fly and I ignored that. Then I ignored that and I continued on and you're still mucking around. Doesn't fly with me. No. Don't want to be here, get out of here. I'm going to say it again. Don't want to be here, get out of here. This is my final warning. Then get out. Sit somewhere else. There's so many solutions. As you're giving me all these excuses, you come up with one solution that solves your problem. My problem is you at the moment. What's my solution? Get out. I'd rather you go to middle school and I don't need you to be in this classroom. Then I don't have to do this and record this as well. You could go, you go work in the middle school because then I'm going to write a report about that I gave you many warnings and you made that choice. So I'm going to say again, my solution to this problem is you go to middle school. That's what I'm saying now. But if you don't like my solution, then I prefer that you keep quiet while I'm doing this. Does that make sense? It's the last warning. Same with you, Mateo. All right, back to this point. When you have a square meter, this is an area. So if you think about that, this is a space. 2 dimensions, you need 2 lengths. So to get 1 square meter, 1 square meter must mean you need 1 meter one side times by 1 meter by the other side. And if you need to visualize that, that's kind of like about a step length. So if you took 1 step across, that's about a meter, and you took another step forward, that's another meter. That space, that square, is what we mean by 1 square meter. Okay, so if you took 1 step forward and then 1 step to a side, that's the space of what 1 square meter would be. Now you can see where the formula comes from. Because it's 2 dimensions, if I wanted to convert square meters to squared centimeters, I would need to convert this one into centimeters. But if you convert this to centimeters, can you see 1 meter is equivalent to how many centimeters again? 100. So you need to times this by 100 for this length. But then if you times this side, this is 1 meter as well, then this 1 meter, because it's 2 dimensions, you actually end up doing it twice. You would actually end up timesing by 100 twice to get centimeters. And because it's twice, now if I asked you how do you find the area in terms of squared centimeters, it'd be 100 centimeters times 100 centimeters. That means 1 squared meter is equal to 100 centimeters times 100 centimeters. And you can see here 100 centimeters times 100 centimeters gives you 10,000. So what did you actually multiply? That's actually 100 squared, because 100 times 100 is 100 squared. That's why the formula, if you notice now, when you're doing area units, the only difference is all of them have to be squared. And the reason why it has to be squared is because you're literally converting each dimension once and then twice. So you times this by 100, you times that by 100, so you end up timesing it twice. That's why the result, when you want to convert from squared meters to squared centimeters, you actually ended up doing more. You ended up dividing or timesing double the amount. That's the reason why it works. Okay? All right, team. So from here, oh wait, did I do this chart wrong? Let me just double check that again. Oh, whoops. Should be the other way around. My bad. Can you guys fix your notes? It's actually times on the top, divide on the bottom. Because if you had 1 centimeter, you need to times by 10. That's right. That's my bad.
So what about the ones with the top one?
Yeah, so the top one means I made a mistake there. That means from centimeters to... Oh, no, it's just because I drew the arrows in a different direction. That's why. Oh, my bad. Now, the top one's correct because of the arrow directions. I assumed the arrow direction was the same, but it wasn't. See how this one is from right to left, but then this one is left to right? So I guess if I fix it to make the arrows correct, it should have been like this. It should have been millimeters to, centimeters to millimeters, meters to centimeters, kilometers that, and then backwards. Then it should, all of this will then change. There we go. So this one should have been times by 1,000, times by 100, times by 10, divided by 10, divided by 100, and divided by 1,000. All right, and the last piece of information. It's part of your notes. HA stands for hectare. You only see that, say, if you ever bought or started looking on realestate.com. If you're buying a house that is a farm or land that has a farm size, they usually use hectares. Out of curiosity, how many people know 1 hectare is equivalent to how many squared meters? No. Much bigger.
10.
More than that?
10,000.
Yes, that is exactly the correct answer. 10,000 squared meters is equivalent to 1 hectare. Now, to get you to visualize what that looks like, 10,000 is the result of multiplying 100 meters by 100 meters in order for you to get an area of 10,000 squared meters, because 100 times 100 is 10,000. But if you want to visualize what this looks like, this would mean instead of doing 1 step across, which is 1 meter, right? 100 meters, one of those 100 meter sprints that you've done, imagine you did a 100 meter sprint one direction, you stop, then you do a 90-degree turn, and you did a 100 meter sprint that direction. That is the size of 1 hectare. Okay, so most houses, if you think about just even that house over there, the depth usually is about 17 to 20 meters. So that means when you're doing a 100 meter sprint, you're doing about 5 times that house forward and then 5 times that house across. So usually it's 20 meters deep and about maybe 15 to 17 meters across. That's roughly how much a land on average should roughly be. But that's a visual image for you. So if you did a 100 meter sprint forward, stop, turn 90 degrees, did another 100 meter sprint, that's what 1 hectare looks like. Okay, that's the space it occupies. All right, team. That's 4C. We'll do some problems together just so you get a feel of it before we write the formulas for 4D. Flip over the page. Flip over the page. All right. Here we go. Let's use your charts. All right, team. Let's do the first question. Example 1. Thanks, team. Example 1. Use the chart that I've got you to fill out just now. We are wanting to convert from squared meters to squared centimeters. Notice the language I'm saying as well. I didn't say meters squared and I didn't say centimeters squared. The proper language is squared meters. And that's squared centimeters. The reason why that is important, especially when later on when you hear your parents go to an auction or buy a house, the auctioneer will not say square or meters squared because that's not the proper term, because there are two ways to measure land. This is a bit of a tangent here. When you buy a house, there is a land. They measure this land and they call it square meters. But when you buy a house which sits on a land, the house has an internal space, right? Which is obviously smaller than the land. They don't measure that in squared meters. They measure that in what they call squares. That's why it gets very confusing. Yeah? The average house has about 24 to 26 squares. But the average land, so land size on most times is about 500, about 500 square meters, possibly 600. But 500 is a relatively decent home. So what's the difference between the two? Why do they measure in squares? Because it's easier to count in this way. A square, so when you say 1 square, which is what they sell when you look at realestate.com and they draw the sort of house plans, 1 square is equal to 9 square meters. If you're wondering what 9 square meters is, have you ever seen the planning of a home? You know those bedrooms? Your bedrooms, on average, even check your own home, they're roughly about 3 meters by 3 meters. Because 3 times 3 gives you 9 square meters. That's 1 square. So the number of squares tells you how many rooms you can roughly fit into a house. And that's what they measure it with. So the auctioneer will say, they'll switch between words. They'll say land size of, 550 square meters, and then the house size of 24, 23 squares. And a lot of people get confused by that because squares measure how many rooms you can fit. Land size, we measure by distance. That's why they're both slightly different. Okay? All right, let's go back to the one at hand. So we're now trying to convert 3.51 squared meters into squared centimeters. Looking at your chart, how do you convert squared meters to squared centimeters? Can I please have, let's go with Leon. What's the method?
Times 100.
Times 100. Squared, because this is area units. Area units, so it's 2 dimensions. So here we go. 3.51 times 100 squared. Now 100 squared means 100 times 100. So if you times 3.51, again, you can use a calculator here. 3.51 times 100 times 100. So here we go. Let's type it on. 3.51 times 100 times 100. That's 35,100. So write in your answer, 35,100 squared centimeters. If you have one of those calculators where you can actually do the power, then the power symbol actually looks like a hat. Looks like that symbol. Okay, so on your calculator, you see that little hat pointing thing or arrow pointing up. That's the power symbol. So on this calculator, it doesn't show it. But if I do 3.51 times, and I want to do 100 squared, see the button on this side has a little arrow? Just over there, there's my little arrow. So if I press that arrow, it's 100 squared. Yeah, on your calculator, if you've got the green scientific one like Sienna's got there, you should have that arrow button. Okay, so then if I press enter, should be the same answer. So if you don't have that square button, you can do it this way. But if you have the square button, you do it this way. All right, next one. How do you convert squared millimeters into squared centimeters? Can I please have, let's go with Tilly. Squared millimeters to squared centimeters on your chart. What does it say?
Divided by 10.
Good, divided by 10 squared because they're area units. So in this case, on your calculator, you would do 150 divided by, and you can either say divide by 10 and then divide by 10 again, or you can say 150 divided by 10 squared, which is 100. Okay, and you get the same answer, so it's 1.5. So the answer here is now 1.5 centimeters, or squared centimeters. That's for area conversions. And the next few is literally just applying your formulas that I gave to you, and you use a calculator to do this. Let's start off with the first one. Example 2a. Lucas, what shape do I have? Rectangle. What's the formula for a rectangle? Let's go with man. Length times width. Good, so we fill this in. Width. Which one is my length? Let's go with Josh. Which one is my length in this diagram? 7. Usually we say the longest side is the length. So 7 times 3. And 7 times 3 is what, Wendy? 21. But don't leave your answers just 21. What are we missing? Good. You must write squared centimeters. Okay, if you don't write the units, I'm going to penalize you in the test. Next one. Example 2b. What shape do I have here? Let's go with Kyle. Good. How do you spell it? Spell parallel first, so parallel, and then ogram. Parallelogram. What is the formula for parallelogram? Let's go with Wilbur. Base times height. Very good. What is my base in this case here? Let's go with Ava. 10 meters. Very good. Base is 10 times 4, and that gives me 40, but I don't finish there.
Square meters.
Squared meters, good. Don't say meter squared. It's squared meters is the correct pronunciation or how you read it.
Yeah.
Next shape, C is a triangle. What was the formula for a triangle again? Let's go, Elizabeth. Good, so half times base times height. Very good. What is my base in this case? Let's go with Elliot. For a triangle, what's my base?
8.
Very good. So it's half of 8 times by height, which is 5. Let's work it out. Half of 8, Bo. Half of 8? 4. So 4 times 5 gives you 20, but you don't leave your answers 20. Squared what?
Square meters.
Squared meters. Very good, Leon. So the answer is 20 squared meters. Very good. Next one. D is a problem-solving one now, so it doesn't fit in the 4 shapes that you've got. But you got to think about, well, what can I do with the 4 shapes to get the area that I want, which is this one. So I want this weird shape, just the area of this inside. Now, I've given you a hint already. I said the total area, which is this space here, is equal to a rectangle. So you see 8 by 10 will give you a nice full rectangle. What do you think the missing bit is?
The missing bit is 3 meters times 10 meters.
Yes, and?
And then you minus it with the standard. Or what?
No, you're right. Yeah.
The area of the triangle. I don't need I don't need half of it.
Very good. You were missing the half, but you got the idea. If you found the area of a rectangle, the entire shape, and you took away the triangle, so minus the area of the triangle, you'll get the leftover bit that you want. So the technique here is find the area of a rectangle, so the entire thing. Work out the entire area. So there'll be 10 times 8 gives you the entire rectangle, all of this. Then I'm going to minus the triangle, so the red bit. I'm going to minus the red bit, then I got the yellow left over. So here we're then minusing area of a triangle. We already know it's half of base times height. And that's what Leon was trying to say before. He was saying that the base is 10. So you said 10 and you multiply by 3. Can you see this length here is 10 and that length here is 10. So this one is your base of the triangle times by the perpendicular distance. That's the height. So 10, 3. So 10 times 3, that's your base times height. Halve it to get your triangle. And you got your rectangle for the entire thing to minus the triangle to get you what you want. So here we go. 10 times 8 is 80. Minus half of 10 is 5. 5 times 3 is 15. And 80 minus 15 gives you 65. Very good. So that's a bit of a problem-solving one. So you know your 4 formulas. It's applying your thinking. How would you work it out? And the hint is to find the entire rectangle and then minus the triangle. That's how you get the leftover. All right. Once you've copied that, can you please flip over? We're on to 4D. 3 more formulas, and that's it. 3 more shapes to identify. So you've got your basic shapes. We're now going to look at some special shapes. It just means different. Different shapes. Here we go. Flip over to 4D. All right, here we go. There are 3 shapes here. All right, listening. Eyes and ears towards the board. Thank you. You got 3 different shapes. When you're doing these exercises, I do want you to draw the shapes. I don't really care about how pretty it is. What I do care about is the notation that you're using. The notations is what makes the shape. It's not the look of a shape. Otherwise, you're assuming. In mathematics, we're all about notation. We're about clarity and facts. So, what is the difference between a kite, which sometimes is called a diamond? Okay, let me just get my pen up. Ooh, what's going on? It's my mouse. Ooh. Oh, yeah, here we go. All right, the kite sometimes is called a diamond. What is the difference between a diamond and a rhombus? Because sometimes the textbook, they'll draw that. If you tilt your head, that kind of looks like a diamond. But the symbols will make a difference between a diamond and a rhombus. How do you know? Very easy. In a kite or a diamond, notice that the opposite sides, listening, opposite sides, they don't equal. Unlike a square, unlike a rectangle, unlike all the other types that you might know, opposite sides are usually equal. In a kite. Thank you. And Matteo, I've noticed that you haven't been taking my notes. I don't know what you're doing, but you're going to show me what you're doing later. And I did say I was going to follow up on you. Because this last month now, it's been 4 weeks, I don't know how much you've actually been doing in my class besides playing games. Right? So I'm going to watch you. You're going to show me what you've done later. Otherwise, I'm sending you an email at home, okay? All right, here we go. So opposite sides are not equal in a diamond. That's one of the hints. So how do you show they're not equal? Notice the dashes. That's 1 dash. This is 2 dashes. So these opposite sides do not equal. That's one of the hints. Versus in a rhombus. What makes a rhombus different to a diamond, even though they sometimes look very similar, is that all sides are the same. So it's very similar to a square. The only difference is a square has 90 degrees. Rhombus doesn't. Okay, so when you get a rhombus shape, look if all the dashes are the same. If you see something like this, that's not a rhombus. This is a kite now. Opposite sides are different. These 2 sides are the same and those 2 sides are the same. That's a kite. Okay, so be careful with the notation. Check if all sides are the same. What's nice for you, formula is the same for both. So if you have to find the area of a kite or a rhombus, you'll likely be able to get the answer correctly. It's just identifying it correctly or not. So fill in your notes. Opposite sides are not equal. All sides are equal for a rhombus. Formula for both the rhombus and a kite is exactly the same. It is half times diagonal 1 times diagonal 2. And what that means is that if you took the diagonal from one corner to the other corner, that's called diagonal 1, times by the other diagonal, so one corner to the other corner, that's diagonal 2. Now in the diagram, I've already given this to you as x, so that's x, and from here to here, that's y, that's the diagonal length. So it's technically x times y. Listening. Same thing with a rhombus. Diagonal 1 times diagonal 2. This will give you, let's call that x and let's call this y. Then it will be x times y. Now, if you're wondering, this one you don't actually need to know, but the reason why this is different to a parallelogram is mainly because the intersection of the two diagonal lines for a kite and a rhombus, the intersection of the diagonal lines are 90 degrees. Copy that down. So formula for kite and rhombus is different, are the same, but it's different to a parallelogram. This is because the diagonals actually intersect at 90 degrees. So that information there is good for those students who do reasoning questions. If you're wondering why, one of the key facts is that rhombus and a kite, they will intersect, diagonals will intersect 90 degrees, whereas a parallelogram doesn't. Okay? That's only for those who do reasoning questions and enrichment questions, and that's a fact to know. And your last one for today, trapezium. How do you know if you've got a trapezium? It's based on these two lines. What are these two lines called? Parallel. The trapezium is the only four-sided shape that has one pair of parallel lines. You see, a square has two. See, that's one pair and then two pairs. Rectangle has the same thing. Has one pair, so those two are parallel, and then these two are also parallel. Rhombus is the same. Rhombus has two as well. A kite has none. So our kite has none, so that's 0. Trapezium is the only one that has one pair. So write that as part of your notes. Only have one pair of parallel lines. That's how you know you've got a trapezium. So you can draw a trapezium many ways. Here we go. This is one way of drawing a trapezium. Here's one pair of parallel lines, and I can draw it down like a 90 degree, and then do that. That's a trapezium. I can draw another pair of parallel lines like this. So one short, one long, and I connect the two ends. That's a trapezium, because as long as you've got one pair of parallel lines, that's a trapezium. Or you could even draw slightly short and slightly longer. As long as these two are parallel, all of these three are trapeziums. The formula is the same for all of them. It's very similar to a triangle because that's where it comes from. The formula is half A plus B. What's A and B? A and B are your two parallel lines. Okay, so A and B are your two parallel lines. Add them together, times by the height. Remember, the height has to be 90 degrees. Not the slant. It's always 90 degrees with each other because you're dealing with, again, two dimensions. Two dimensions are perpendicular to each other. And that's it for your rules, and that's for C4D. So you just need the rules, have them all on a sheet somewhere, because at the end of this chapter, you just need to be able to apply the rule to the shape. So as long as you can identify the shape, use the rule, use a calculator, and that's how you get your answers. Okay? I'm going to stop the video there because it was quite a long session on it. I'm going to stop here.